This tutorial will cover mat foundation loads and member loads. Firstly, I will specify a few points which apply to all types of mat-specific foundation loads. The loads specific to mat foundation, which are point, line, quadrilateral, and circular pressure loads, are independent of any object, such as column position, beam, or mesh node. Instead, they are defined by their x, y, and z coordinates. STAAD Foundation Advanced will automatically distribute the load on the mat foundation even though the loads are not associated with an object. The mat-specific loads can be simulated as an external static load, such as heavy equipment. For example, a quadrilateral load can simulate the pressure of a water tank during construction. All of the mat foundation loads are added in the selected load case next to column reaction loading. Also, the mesh needs to be remeshed if a mat load is added after the mesh generation process. Each load can be added in two ways. Firstly, by selecting the icons in the Tools menu. Using this method, the loads must be added on grid nodes. Grid nodes are completely separate from mesh nodes and are defined by their x, y, and z coordinates. The coordinates of the loads are assigned according to the selected nodes. It's important to note that when creating mat-specific foundation loads with the icons under the Tools menu, both the points where you initially click and let go must be a grid node. Then you may enter the required information in the pop-up wizard. Information generated by node selection can still be edited through this wizard. The second method to add mat-specific loads is by selecting the desired load under Loads and Factors in the main navigator. Load positions are given according to the user-specified coordinates. I will briefly go over creating all four types using this method. The first and most simple mat load is the point load. Click Add a Point Load on the main navigator to enter the required information. Remember that each load is being added to a load case, so be sure to have the correct one selected before creating the load. I will give it a force in the y direction of -100 kips and a moment in the z direction of 60 kip feet. You can reference the column positions under Foundation Plan in the main navigator to create a point in relation to the supports. I will create the point load in the center of supports 1, 2, 4, and 5. The next mat load is a line load. Click Add a Line Load and specify the force in units of force over distance. I will put -5 kip per feet. Then give the starting x, starting z, ending x, ending z, and y values for the line. Then click Add to create the load. Unlike column reaction loads, there is no need to assign loads because the place of application is already specified. Quadrilateral loads are a pressure load. The user can specify 4 points which define the boundary of the quadrilateral load. I will put -50 kip over feet squared for the pressure, and then enter the coordinates of each point. The first point is x1, z1, the second is x2, z2, and so on. Now you can see the quadrilateral load in the geometry view. Finally, to add a circular pressure load, input the pressure, and then enter the x and z coordinates of its center. Then enter the radius of the circular pressure load. The number of divisions is purely for viewing purposes. As you can see, it controls the number of divisions of the circle. There is also a linear load option. For the default pressure load setting, the pressure is applied evenly on the whole area of the circle. However, selecting linear load changes the units from force over area to force over distance, and the load is applied as a line load along the circumference of the circle. I will now begin to discuss the three loading types that may only be added on beams and mat foundation. They are uniform, concentrated, and trapezoidal loads, and are referred to as member loads. Member loads have to be added on beams which must start and end at a support. The orientation of the beam is defined by the starting and ending nodes in which the beam was created in STAAD Foundation Advanced. For example, if you created the beam by clicking on support 1 first and then support 2, the orientation of the member will go from support 1 to support 2. This orientation is used as reference to define all positions of the following member loads. I will briefly go over the creation of a trapezoidal member load, because all three are fairly similar. First, specify the force at start and force at end, and the direction of the load. Then give the start distance and end distance in which the load will be applied on the beam. Click Add to add the trapezoidal load to the load case. However, similarly to column reaction loads, member loads must be assigned to individual beams. This has been a tutorial covering all mat-specific loads and member loads in STAAD Foundation Advanced. Thank you for watching.